Good afternoon, everyone, or good morning or good evening, depending on where you're listening in from. My name is Katie Flower. Welcome to today's ASSA ABLOY virtual instructor-led training on understanding basic egress hardware. We will be basing today's information on the requirements found in the International Building Code 2015 edition. You will receive within 24 hours after this course an email thanking you for your attendance. You can use that as proof for continuing education for 1 hour worth of credit. And additionally, this session is being recorded. Will be on ASSA ABLOY Academy on the virtual instructor-led training page, top right-hand corner, so that you can review it as frequently as you would like. And if you have a colleague that happened to miss this, you could also have them go there and take a look. If you have any questions today, there is a Q&A button on your Zoom panel. You can type in your question at any time. I will be monitoring that. I will also save some time at the end for any questions that you may have. When it comes to codes and standards, there's a big difference between the two. A code is something that is adopted into law, either in whole or in part by your state, city, or other jurisdiction. And the code is written and revised every 3 years, but until it has been adopted by version by your state or whatever the local jurisdiction, it does not take effect. For example, the IBC 2021 edition has been out for several months, but no state has adopted it yet. You can use the website iccsafe.org to find which IBC has been adopted in your state or project area. And that is kept up to date as well. You can link to whatever city or local jurisdiction that you may have to see if there's any modifications to that as well. A standard is a set of criteria by which everything else is measured or compared. Some of the standards that we use in this industry to specify and select the appropriate code compliant hardware are NFPA 80, which is the standard for fire doors and hardware, and ANSI A117.1, the standard for making hardware and doors accessible. And those are referenced by the code. So standalone, those standards don't mean much until they're referenced by the code. Once they are referenced, then they become a part of the code. Here's a question for you before we get into the definition of means of egress and a few other things. I just want you to think about this for a minute. How long does it typically take a person to reach an exit in a commercial building during a fire? Does it depend on the height of the building? Does it depend on the square footage of the area of the building? Does it usually take 1 to 2 minutes, or does it take 4 to 5 minutes? Just think about that for a second. And the answer is it takes the average adult 1 to 2 minutes to reach an exit. And part of that is because of the way that the building codes are written. Your means of egress consists of 3 separate distinct parts. It is a continuous and unobstructed path of vertical and horizontal egress travel from any occupied portion of a building or structure to a public way or safety. And it consists of the exit access, the exit, and the exit discharge. The exit access is that portion of a means of egress that leads from an occupied portion of a building or structure to an exit. And that's the area that's shaded in gray. Because we have rules for the length of travel distance to an exit, whether the building is sprinklered or not, what type of construction the building is made out of, whether it's concrete or wood studs with sheetrock and that kind of thing, that will determine the maximum travel distance to an exit. But typically, it's no more than 200 feet. It could be a little longer if you have an exception, but to get to an exit, 200 feet really doesn't take that much time. An exit is so much more than just a door. And yes, it does include the exterior doors at the level of exit discharge, but also it includes vertical exits, stairs, and horizontal exits, which are usually cross-quarter doors that are going to be fire rated based on the height and size of the building, as well as the travel distance. And Table 716.5 tells us what the ratings of the exits are required to be. The exit discharge is that portion of a means of egress between the termination of an exit and a public way or safety. I mentioned horizontal exits earlier. They are consistent of fire barriers and fire-rated door assemblies. They're intended to compartmentalize portions of a large building. So the fire compartment can be no greater than 22,500 square feet. If you're on a very large floor plan, whether it's a hospital or a school or whatever, and you can't reach a vertical exit within that 200 feet or whatever the travel distance maximum is, a horizontal exit is a great way to break up the building into several fire compartments. Once you've reached the opposite side of the double egress door, if you're leaving where the fire began, you are now safe, just like you were in a vertical exit stair. You're safe from where the fire started. Before we can select hardware that is code compliant to meet means of egress, there are a few more things that I want to cover. The code is written around ordinary risk, ordinary hazard, and the risk factors are based on two main factors when it comes to door hardware, but also other parts of your building or structure. And that is the occupant load, which is how many people could be present at any given time, and the occupancy type, how the building or space is used. Those two factors together help decide whether or not your hardware can lock the door from the egress side or whether you need to have one operation to get out. The quantity of exits depends on the occupant load. When we have 1 to 500 people, you need a minimum of 2 exits. And remember that exits are more than just doors. They could be a stair, they could be a horizontal exit, an exit passageway, and items like that. When you have 501 to 1,000 people, we need a minimum of 3, and more than 1,000, we need 4. Whether it's an exit or an exit access door, most of the time your hardware selection will be the same. There are some exceptions to that. But the occupant load is something that can be calculated based on the square footage of the area and the use, the occupancy type. I mentioned that the code is written around ordinary risk, ordinary hazard, and then it's modified to either be more restrictive or less restrictive. And that's where the exceptions come in. So some occupancy types that are considered ordinary risk would be Group B, business, Group M, mercantile, and Group R, residential. The high-risk occupancies are Group A, assembly, Group E, educational, and Group H, high hazard. When it comes to hardware, instead of being granted exceptions, there are more restrictions. For example, exit devices are required in the high-risk occupancies. They're not required in other occupancies. You can use them, but they're not required. Delayed egress, which we are not going to be getting into special locking arrangements in this session today, but delayed egress, for the most part, are not permitted in high-risk occupancies either. And then low risk would be Group I, institutional, which includes your hospitals, nursing homes, detention and correctional facilities, and the like. And those, because of the presence of staff, would be considered exceptions where you could lock the door on the egress side using controlled egress or into a patient area if it's behavioral health or something like that. And there's also exceptions on fire-rated doors where you don't need closers on patient rooms. Ordinary risk occupancies, I mentioned Group B, business, which is for the sale of professional services. This includes colleges and universities. College and university, some people think, well, that's educational. Educational is K through 12. and you're an adult at a college and university, you're paying for the services. And so they consider that Group B business, unless it's a dormitory, which is then going to be Group R residential. Group M mercantile is very similar to Group B business, but instead of selling professional services, they're selling merchandise. And Group R residential, for the purposes of the building code, we're talking about hotels, apartment buildings, dormitories, places like that. Our high risk occupancies, I mentioned Group A assembly. That's where you're gathering 50 or more people together for purposes such as civic, social, or religious functions, for recreation, entertainment, food or drink consumption, or awaiting transportation. Places like nightclubs, restaurants, movie theaters, football stadiums. You're dealing with large crowds of people that are not related by blood, that don't necessarily frequent the place, so they're not familiar with their surroundings. And because you have a lot of people packed into a smaller place, they all try to reach the exit at the same time if there's a fire. The leading cause of death in a fire is smoke, but the number 2 cause of death is panic, which is the pushing and shoving and trampling of each other when everybody tries to reach the exit at the same time. Group E educational is K through 12, including nursery schools and some daycare. And even though they do fire drills, school-age children are prone to panic. And Group H, high hazard, regardless of the occupant load, is considered high risk because the materials inside are highly flammable or likely to explode. And then our low risk occupancies, I mentioned Group I, institutional, and that would include your assisted living, hospitals and nursing homes, detention and correctional facilities, as well as adult and child daycare, where the patients are staying 24 hours a day and they have care. They are not capable of self-preservation. They need staff to help evacuate them. Then we have what's called a mixed occupancy or mixed use, where you have a commercial building and there's more than one occupancy in it. There's 2 basic types. If you have a non-separated occupancy, you've got 2 or more occupancies that share the same building and they share the same egress components. An auditorium in a college or university building. The college university building is a Group B business. The auditorium, having more than 50 people, is Group A assembly, and everybody empties into the same corridors and the same stairs and the same exit doors. Then you need to provide hardware based on the more restrictive egress requirements, which would be Group A assembly. The other type is separated occupancy, where you've got 2 or more occupancies that have separate egress components. For example, you may have a ballroom or a meeting room in a hotel. The hotel is Group R residential. The ballrooms and meeting rooms are Group A assembly, but they're in their own wing and they have their own egress corridors that lead directly to the outside, and they don't share the same egress components or corridors or doors as the hotel, and therefore you would follow the requirements for each occupancy individually. The Group R, you would follow those rules, and Group A assembly, you would follow the more restrictive rules. The minimum clear opening width for a door and a means of egress is 32 inches clear unless by exception. That happens to match ADA, and it's nice when 2 codes or a code and a standard match each other. If 2 codes conflict with each other, you need to follow the more restrictive requirements. So 32 inches minimum clear, that's measured with the door open 90 degrees from the face of the door to the face of the stop. In I2, which is your hospitals and nursing homes, because they're evacuating patients in their bed, the doors need to be a minimum 41.5 inches clear in order to move the beds from the patient room down the hallway into a stair or into a horizontal exit, an area of refuge to await the next step. And the maximum leaf width for doors and a means of egress is 48 inches. And that's because swinging doors, when the wider they get, the more difficult they are to keep from sagging. There's a lot of downward force on that top hinge location. And in order to maintain our means of egress continuity, 48 inches is the maximum leaf width. I mentioned that it's measured from the face of the door to the face of the stop, and that does not include your hardware. You don't have to take the hardware into consideration. And that's because the hardware typically does not project more than 4 inches off the door, and it can't be lower than 34 inches above the finished floor. And so because of that, we measure from the face of the door to the face of the stop. When it comes to the height, there is a minimum height. The minimum height in a means of egress is 80 inches clear opening height. There is an exception for door closers and door stops that are permitted to be 78 inches minimum above the floor. They don't specifically mention maglocks in the 2015 edition. It is something they will be addressing in future editions of the code. However, you can see in that picture that the maglock hangs down into the clear opening height. So you want to be careful not to use a surface mounted maglock on a door that's 6'8", because it will encroach on that clear opening height. A 7-foot door, depending on the manufacturer of the maglock and any shim plates that you may need during the installation, you have to be careful, but it should be within that 78 inches minimum above the floor, and you should be fine. Always worth double checking. And if you can't use surface mounted, then you could use the concealed, the shear, and then you don't have any obstructions. Egress doors shall be of the pivoted or side hinge swinging type unless by exception. And there are many exceptions for revolving doors, sliding doors, and things like that. But unless by exception, the doors need to be side hinged or swinging, and they need to swing in the direction of egress travel when serving a room or an area that has an occupant load of 50 or more people. The picture that you have, you've got individual offices. This is a Group B business, and each individual office has one person, but there's a total number of 100 offices on that floor. You notice that the doors swing into the office, that's fine, but the stair door swings in the direction of egress travel because there's more than 50 people on the floor. That doesn't have anything to do right now with the hardware that's on the door. That's just the swing direction. The door has to swing in the direction of egress. If you have Group H, high hazard occupancy, regardless of the occupant load, the door needs to swing out in the direction of egress. Encroachment. When a door swings onto an egress corridor, it shall not reduce the required width of means of egress by more than half, and when fully open, not project more than 7 inches. And that does not include the hardware on the corridor face of the door. So again, you're measuring from the face of the door back to the wall. And just as a note, the purpose is if you're having a crowd of people exit down this corridor and you've got classrooms that are all emptying, as these doors are opening, you don't want them to become an obstruction or an impediment to egress. A better way is if you pocket the doors or recess them so that they can open 90 degrees against the wall and you still have the full width of the corridor. Unless specifically permitted by this section, and all of our means of egress requirements are found in Chapter 10 of the IBC. There are some special detailed requirements based on occupancy type in Chapter 4, and you're going to use the two together no matter which version of the code that you're under. But most of our door hardware will be in Chapter 10 of the IBC. So unless specifically permitted, egress doors shall be readily openable from the egress side without the use of a key or special knowledge or effort. And they need to have one operation in order to get out, unless by exception. When you're looking at or reviewing products, you're looking for cut sheets that say inside grip always free. That means that there is no locking on the egress side. Here is a door that has a deadlock built in. It's a mortise lock, and you see that it takes one operation in order to pull back both the deadbolt and the latch bolt, one operation to get out. That is code compliant. There are some deadbolt functions that will not be retracted by the lever, and those can only be used in a means of egress with the special exception. Door handles, pulls, latches, locks, and other operating devices shall be installed 34 inches minimum, 48 inches maximum above the finished floor. This matches what ADA says. So again, it's nice when two codes or a code and a law match each other, then there is no conflict. There's also this exception if the lock is used for security purposes only and not used for normal operation, they're permitted to be at any height. And the type of locking this is talking about typically would be a deadbolt of some kind, and you see them in the bottom rail of glass doors going into the floor. You see them sometimes at 60 inches above the finished floor for security purposes only. The door will be unlocked while it's open to the public, and therefore those security locks can be at any height. Here are the list of some of the exceptions when it comes to preventing operation of doors from the egress side. Number one, and this is left pretty open because the AHJ, the authority having jurisdiction, will be able to apply based on the type of occupancy and the type of use. But in places of detention or restraint, you are allowed to lock the door from the egress side. This does not give the building owner the right to choose what they consider detention or restraint. It's up to that authority having jurisdiction. And most commonly, it's going to apply only to institutional Group I occupancies, detention and correctional facilities, jails, hospitals, nursing homes, any place where for the patient's best interest or for the person's best interest, you're locking them in, and that is the definition of detention or restraint. Number two, another exception is when you have buildings in occupancy group A, which is assembly. Think about a restaurant in this particular scenario. When you have less than 300 people, group B, business, F is factory, M is mercantile, and S is storage. And in places of religious worship, the main door or doors are permitted to be equipped with key-operated locks that are readily distinguishable as locked, and a sign is posted, door to remain unlocked when this space is occupied. What this is talking about is double-cylinder deadlocks. And you see them in restaurants, you see them in businesses, you see them in stores quite frequently. The door is unlocked in the morning by whoever or whatever time of day that they're open for business. There is a sign posted on or near the door, and the only time that they can lock that door is after hours. Because it's on the main door, there's always one other exit, which is unlocked. This is only permitted on the main entrance or main doors. And if it's a restaurant, they're not going to sell any food if they don't unlock that door. They have to be unlocked to be open to the public. And so it doesn't make sense for the owner to lock the door if they want to have people in there. And that's why it is an exception that has been around for a long, long time. The AHJ can revoke this if they find out that the owner is not following the rules. They can make them take the deadbolt off the door. When we have a pair of doors and they're needed for egress, but both leaves are not necessarily, the active leaf is what's required for egress. The inactive leaf can have approved automatic flush bolts, provided that the door leaf that has the automatic flush bolts does not have any surface mounted hardware. Automatic flush bolts will unlatch as soon as the active leaf is unlatched. and you can push the door open, but you can't open the inactive leaf first by itself because the automatic flush bolt relies on that active leaf to keep the latch engaged. And that's why you can't have any surface mounted hardware. You don't want to trick somebody into thinking they can use the inactive leaf. Another exception is when you have Group R occupancy, which is your residential, think of hotel, apartment building, dormitories, and the like. Doors from individual dwelling or sleeping units having an occupant load of 10 or less are permitted to be equipped with a night latch, a deadbolt, or security chain, provided that such devices are openable from the inside without the use of a key or tool. So normally we are required to have one operation to get out, but because of the low number of people and the low risk or ordinary risk Group R occupancy, they will grant this exception to have one additional operation as long as it's not keyed. Another exception is when you have fire exit hardware, fire doors, that the minimum elevated temperature has disabled the unlatching mechanism in accordance with the listed fire door test procedures. This covers not only the exit device itself, which has a fusible link and it disengages the latch so that the doors will stay closed and latched, but also any thermal pins used for less bottom rod, surface, or concealed vertical rod exit devices. Manually operated flush bolts or surface bolts are not permitted. And remember, this is from a standpoint of a means of egress. There are exceptions now. Exception number 2, when you have a pair of doors that serves a storage or equipment room that's not normally occupied by people, manually operated edge or surface mounted bolts are permitted on the inactive leaf. And number 3 and number 4 are both very similar. Number 3 is when you have a pair of doors serving an occupant load of 50 or less in Group B business, F factory, or S storage occupancy, then you can have manually operated edge or surface bolts, and the inactive leaf shall not have any surface mounted doorknobs, panic bars, or other similar operating hardware. Number 4 is very similar to 3, except if it's a fully sprinklered building, then there is no maximum occupant load for your Group B business. And then another exception is when you have a pair of doors for patient care rooms, the patient bedrooms in hospitals and nursing homes, you can have self-latching edge or surface mounted bolts on the inactive leaf, provided that the inactive leaf is not needed to meet the egress capacity requirements, and the inactive leaf shall not have any doorknobs, panic bars, or similar operating hardware. If we look at the door in the picture, that's a pretty common patient bedroom door, unequal leaf pair. The active leaf is wide enough, it meets the 41.5 inches minimum, but every now and again, they want to open up the smaller leaf to move that bed or something through and give you more full room. A self-latching flush bolt like the bottom picture, the door stays latched the entire time until you push in on that button. And this exception says that is permitted. Unless by exception, the unlatching of any door leaf shall not require more than one operation. And what I just gave for examples of where you can use automatic flush bolts, manual flush bolts, and self-latching flush bolts, those are the exceptions to this. So if you've got exit devices on each leaf, you can't have an overlapping astragal or something that is going to stop the use of one leaf without opening up the other. Each leaf has to latch independently and be usable independently. Exit devices, they're not required in every occupancy type. Here is exactly where they are to be located. Door serving Group H, high hazard occupancy, regardless of the occupant load. And our high risk occupancies, Group A, assembly, and Group E, educational, when you have 50 or more people. So if it's a classroom and there's 50 students or more, you need exit devices from the 2 exit access doors. If it's a gymnasium, a dining room, any place where you've got 50 or more people in assembly or educational occupancy, and it needs to latch or lock, then you need to use an exit device. Push pull, if the door doesn't need to latch, if it's not a fire rated door, then you could use push pull. You don't need to latch and put an exit device unless the door needs to latch. And electrical rooms with equipment of 1200 amps or more, they also require exit devices. I will say that the National Electrical Code is different for each state. So look up what that benchmark is. In some states, it's 600 amps. In others, it's 800 amps. The IBC says 1200 amps. Always check your National Electrical Code for what is in place, in force in your area. If you do use exit devices, they could be the modern style, like the one on the bottom, or the crossbar type, the one at the top. But the actuating portion, the part you push in on, has to extend at least half the width of the door. Panic hardware can be used on non-fire rated doors and can have mechanical docking, where you push in on the exit device bar, use an Allen hex key or a keyed cylinder, turn it and hold that latch in the retracted position. That is okay. Mechanical docking is okay for use on a non-fire rated door. Panic hardware is listed UL 305. When you do have exit devices to go on fire rated doors, they need to be labeled both for panic UL 305 and for fire UL 10C. Additionally, they can't have mechanical dogging. You could use electric latch retraction, or you could use electric dogging that's tied to the fire alarm system and will release and latch at the time of fire. The part you push in on, the actuating portion, must extend half the width of the door and no more than 15 foot-pounds to release the latch. I haven't seen any questions come through yet, but if you have any questions, now is the time to go ahead and type them in. And while you're typing in your questions, I want to point out that we do have an ABLOY egress calculator. It's free. It's a free tool for everybody to use. You can use it on your desktop, a tablet, or your smartphone, and it's egresscalc.assaabloy.com. It's based on the IBC, the International Building Code. It can help you verify what code compliant hardware